Good evening. It is 8:38. Mr. Mac is super sick, but I wanted to get this video out to you so you can prepare over the weekend and you can have this to refer on Friday. So hopefully you'll take some time and listen to all the important things. All right. When we tackle these problems, and we have a whole slew of problems that we're doing here, we have to figure out what are we doing? What's happening in this expression? And to be honest, there are only three things that are going to happen. You're either going to simplify, you're going to multiply, you're going to divide. Sorry, I said three, four, five. You're going to simplify, you're going to multiply, you're going to divide, you're going to add, and you're going to subtract. So we're not adding and subtracting here, we're multiplying. And so we like when things are multiplying when they're factored because we can cancel like over like. What this is really saying is 8x squared over 4x times x minus 3 over x minus 3. And we know anything over itself equals 1. So it cancels. It doesn't cancel to make 0. It cancels to make a 1. This value is equal to 1. And we know that whenever we multiply by 1, we get our original value. At this point, we're left with 8x squared over 4x. Now we have to simplify. These are still multiplying. So this is 2 times 4 times x, and this is 4 times x. The 4 cancels to make a 1, the x cancels to make a 1, and we're left with 2 times x in the numerator. So my answer is going to be 2x. These cancel to make values of 1. Now, these are not multiplying each other. It's not a product. This is addition and subtraction. It is still simplifying, but we can't cancel the 6 and the 12 because it's being added to 15x squared. So what we want to do is we want to factor this. This is our first step, is factor the numerator. We look at the coefficients. We can take out a 3. We look at the variables. We can take out an x squared. So if we take 3x squared from 6x to the third, you're left with 2x. You take 3x squared from negative 15x squared, you get negative 5. And then we do the same thing with the denominator. Now, if you need to do, and we'll talk about factoring, we know that factoring is just doing prime factorization. And we'll show this technique only on this one. So 2 times 2 times 3, that gives us 12 times x, and then negative 30 x, well, that gets broken into 2 times 3 times 5 times x. If we're looking for a greatest common factor, the C tells us to circle what they have in common. They have a 2 in common, they have a 3 in common, and they have an x. So my GCF is 2 times 3 times x, or 6x. That's the largest number I can factor out of both of these. So 6x goes on the outside there. And if we take 6x from 12x squared, we notice that what is left over, it goes inside my parentheses. That 6x times 2x gives me 12x squared. And we see when we take a 6x from, I forgot the negative, sorry, negative 1, we're left with negative 1 and 5. So that leaves us with negative 5. That's factoring. We've factored it out. We can always check by multiplying it back and getting the initial. Okay, now much like problem number 1, we've got these quantities that are identical, and those quantities are multiplying. Because they're multiplying, that allows us to simplify it. We're left with 3x squared over 6x. Now we're going to simplify. We can write it out if you want. Because they're multiplying, we only separate things being multiplied. Not addition and subtraction. We didn't break this into 2 times 2 times 3, and then this. We didn't string this out and do prime factorization, okay? So we did it each one to find. And so So the 3's will cancel, the x's will cancel, and we're left with x over 2. That 2 is in the denominator. Make sure it stays in the denominator. And that's my answer. Again, nothing's multiplying here, so I can't cancel anything. I have to factor. I want to turn addition and subtraction into multiplication. And we're going to factor using a times c. Now, I really do expect you to be good enough to visualize this, to see factors of 21 subtracted equal -1. But if you got to do a times c, okay, not the most efficient. 1 and 20, 2 and 10, 3 no, 4 and 5. My signs are different, and the bigger is negative. And this gives me -1. That's my middle. So I'm going to use 4 and -5. So this becomes x squared plus 4x minus 5x minus 20. I'm doing this part right here. And now we can factor out an x, giving us x plus 4. We're going to factor out a -5, giving us x plus 4. And we know we did it correctly because those are identical. And you are left with, so this factors x plus 4, x minus 5. And now we're going to do the same thing with this one. Okay, we have a times c. We have 1. Well, we'll do it here. We'll do 1 times -15 is -15. Factors of 15 are 1 and 15, 3 and 5. Signs are different. Bigger is negative. These are positive. This is -2. So that's my middle. So I know I'm going to take 3 and 5, -5, excuse me. So you get x squared plus 3x minus 5x minus 15. We're going to factor out an x, giving us x plus 3. We're going to factor out a -5 again, giving us x plus 3. And if we want to check, -5 times x is -5x. -5 times 3 is -15. And these are the same, so I know I did it correctly. X minus 5. And this factors to x plus 3, x minus 5. Now these are multiplying, so that's good. Multiplying, multiplying. Since they're multiplying, we can cancel the binomials, leaving us with x plus 4 over x plus 3. And that's my answer. Okay, now nothing's adding and subtracting. Everything's multiplying. That's multiplying. That's multiplying. This is multiplying. That's multiplying. That's multiplying. So we want to cross-cancel. Everything's already multiplying. This is what our goal is, to get things multiplying. So we can cross-cancel numerators and denominators. 27 and 9 becomes a 3. We have 16 and 20. 4 goes into those. 4 goes into 25 times. 4 goes into 16 4 times. I have a squared here and a squared here, and that's going to be 1. I have a b here. I only have 1. That's to the first. And I have 5 of them here. So this becomes b to the 4th. And I'll circle it so I don't lose it. I have x squared and x, so I'll take 1x from here and 1 here. I'll circle it so I don't lose it. I have 2 down here. I'll take 2 from here, which leaves me with 1 of those. So what do we have left here? We have 3 b to the 4th, 5 xy. So 3 b to the 4th, xy. Oh, we got a 5 in there. Almost lost the 5, circled. So let's erase that and correct it. Times 5 times b to the 4th times x times y over, what's left in the bottom? These all cancel, a 4. Okay, now I can't leave it as products. I'm going to simplify it. So 15b to the 4th xy over 4. We want our variables to be in alphabetical order. So b is going to come before x and y. All right, now we're multiplying. We've got some things being added and subtracted, and then we've got multiplication and things being added and subtracted. I can't cancel these. I can't cancel the x's. They're being added and subtracted. I need to turn this into multiplication. So I'm going to factor each one. I've got x squared minus 3x plus 2. And I'll just let you know, it's factors of 2. The signs are the same. They're both negative. So you have negative x and you have negative 2x plus 2. That makes my negative 3x. That's my check. We're going to factor out an x. You get x minus 1. We're going to factor out a negative 2. And we get x minus 1, x minus 1, x minus 2. Okay, so we'll put this over here. So this is x minus 1, x minus 2. This are factors of 15 when added equal negative 8. So I'll just show you what that ends up being. X squared, that's minus 5. Well, we'll do 3x because technically 3 would come before. 3x minus 5x minus plus 15. Factor out an x, x minus 3. Factor out a negative 5, x minus 3. Just make sure, yep, that makes positive. So x minus 3, x minus 5. So that goes, this is this one, that goes in the denominator. X minus 3, x minus 5 times, now we'll do this one, and factors of 12 when subtracted. So, and getting positive 1, so that's going to be negative 3x plus 4x minus 12. That gives me my positive 1. And that gives us x, x minus 3. We'll factor out a 4, giving us x minus 3, and x minus 3, x plus 4. X minus 3, x plus 4. And this one, we'll do this. So you have x squared, you got factors of 8 when the signs are different, and ending up with a positive 2. So that's minus 2x and positive 4x minus 8. That's x, x minus 2. That's plus 4, x minus 2, x minus 2, x plus 4. So x minus 2, x plus 4. Okay, now everything's multiplying. That's what we were looking for. So numerators, sorry, my nose is absolutely dripping. Numerator, denominator, numerator, denominator, and we're left with x minus 1, x minus 5, and that's going to be my answer. Let's move, whoa, sorry, didn't mean to do that. Let's move all of this down, please. Good. And so my answer is x, no, not in blue. In black, x minus 1, x minus 5. That's a horrible 5. That doesn't look like a very good 5. Let's restart it. And that would be my answer. Okay. Same thing here. I would factor first. I know we have to notice that we're doing division, but I would factor each one of those. So these are a little bit more tricky. You got 6 times 14. And 6 times 14 is going to give you, what's that, 28? No, not 28. Hello. It's going to give you 84, not even close, negative 84. So you got factors of negative 84, 1 and negative 84, 2 and negative 42. So we end up with 4 and negative 21, which equals negative 17. So these are going to factor. That's going to factor to 3x plus 2 and 2x plus 7, minus 7. That makes negative 14. This makes positive 6. This is positive 4 and negative 21, which gives us negative 17. And then 3x squared, that's going to factor. 3 times 8 is 24. Factors of 24 are 2 and 12. The signs are the same. 2 and 12 makes 14. So this factors to be 3x plus 2 and x plus 4. So we got 3x squared. You have 8. And then you have positive 2 and 12, which makes 14. Now I'm going to write it as division because I'm just factoring. This is the difference of squares. You should recognize difference of squares. 2x minus 7, 2x plus 7. And then this is going to give us, what's that, 56, and 7 and 8 add up to 15. So this is going to give us 2x plus 7 and x plus 4. So that gives us 28. This gives us a 2x. This is 7 and 8, which gives us 15. Now I'm going to convert the division to multiplication. The left side stays the same, 3x plus 2. It's keep, switch, and flip. And then this is 3x plus 2, x plus 4. Now the denominator goes to the numerator, 2x plus 7, x plus 4. And the numerator goes to the denominator, 2x minus 7, 2x plus 7. And now we're going to cancel because everything is multiplying. So we have a 2x minus 7, 2x minus 7. We have a 2x plus 7. We have an x plus 4. We have a 3x plus 2 and a 3x plus 2. And remember, these cancels are equaling 1. So my answer is 1, not 0, 1. When everything cancels, it makes 1. All right, here's our first addition and subtraction. With denominators, we notice that all of our denominators are the same. We have like denominators. When we have like denominators, we're going to combine their numerators. So we're going to put it over one numerator. So negative 3 plus 8 minus 3 over 4x squared. Negative 3 plus 8 gives us 5. And 5 minus 3 gives us 2. That's what our numerator. And then we just bring over our denominator. And now we're not done. We have to simplify. You should always be thinking simplifying. And I'm looking for a common factor. And we get 1 over 2x squared. Good. That was really quick. All right. These are unlike denominators. So we have to find a common denominator. We find a common denominator by doing the prime factorization, which is 2 times 3 times x. You can't write 6 times x. 6 is not prime. We want to break it down into its prime factors. And now LCM, what do they have in common? They have a 2 in common. They have an x in common. So a 2 and x, and then the leftovers. L is for leftovers, 3 and 2. And this creates our LCM, our common denominator. So 2 times 3 is 6, times 2 is 12. 12x. That's going to be my denominator. Now I have to do equivalencies. I have to take this fraction that is over 6x, and I have to create an equivalent fraction over 12x. So we ask 6x times what gives me 12x? 2. So I'm going to multiply this by 2. Now, we have to multiply everything by 2 because 2 is multiplying all the parts up there. So 2 times 3x is 6x. 2 times 4 is negative 8. 6x minus 8. Now let's do our other fraction. We have 2x minus 5 over 4x equals what times 12x? So what times 4x gives us 12x? Well, that would be 3. So we're going to multiply this by 3, and we, again, have to distribute. So that's 6x minus 15. 6x minus 15. Now that we have like denominators, we can combine their numerators. We can write it on the same fraction. So 6x minus 8 minus the quantity, 6x minus 15. That's the tricky part. That's the part students don't understand. This negative is the opposite of both of these terms. So we do this quantity. 6x minus 8 minus 6x plus 15 over 12x 6x and negative 6x cancel to make 0. When we add and subtract or opposites, they cancel to 0. And then you have negative 8 and 5, which makes 7 over 12x. And I can't simplify that any further. Again, adding and subtracting. Now, this denominator is a binomial. These were monomials. That was a monomial. That was a monomial. This is our first binomial. So I want to factor that denominator. Not the numerator, the denominator. This is x minus 5, x plus 5. That's the difference of squares. Now I look and I want to do the prime factorization. The prime factorization of x plus 5 is x plus 5. We can't separate things being added or subtracted. X minus 5, x plus 5. The prime factorization is x minus 5 times x plus 5. We can separate those because it's being multiplied. We're going to do the LCM. What do they have in common? They have an x plus 5 in common. What's left over? The x minus 5. So my least common multiple, I'm not going to multiply it back out. I'm going to leave it as x plus 5, x minus 5, so I can see when I have to do equivalencies. Okay, so I'm going to create new fractions with x plus 5, x minus 5. Now, so we're going to take 3 over x plus 5 equals x plus 5, x minus 5. So what do I have to multiply x plus 5 to get this? Well, I got to multiply by x minus 5. That's what's missing. So we'll multiply this by x minus 5. 3x minus 15. That is my new numerator. This is equivalent. This is an equivalent fraction to this with this denominator. We should notice that those are the same. So that's just going to give us 2x plus 7. We have like denominators. Now we're going to combine all the numerators. So 3x minus 15 plus 2x plus 7 all over. Hold on. Oh, my nose is like a faucet right now. X plus 5, x minus 5. All right. Let's combine like terms. We have 3x and 2x, which makes 5x. We have negative 15 and positive 7, which makes negative 8 over x plus 5, x minus 5. Now, I can't factor this, and I can't cancel the 5s or anything of that nature because this is adding and subtracting. This is good because it's multiplication, but that is my answer. All right, now we got subtraction. We again have denominators. Let's turn the denominators into products. I can't separate that and change it. This is going to be x plus 5, x plus 3. Signs are the same. Both are positive. Inside is 5. Outside is 3. That gives me my 8. X times x is x squared. 5 times 3 is 15. We're not going to factor this. I saw some students factoring this. You are not going to factor it because we have to combine all the numerators. If it's products, then we're not going to be able to add it or subtract it from this. So right now we're still looking at the denominators. We got to find a common denominator. So you got to stay focused and understand where you're going with this problem. So I got to find a common denominator, x plus 5. The prime factorization is x plus 5. X plus 5, x plus 3 breaks up to x plus 5, x plus 3. My LCM, what do they have in common? They have an x plus 5. What's left over? They have an x plus 3. And that's my common denominator, x plus 5, x plus 3. So let's convert both of these denominators. We're going to find equivalencies. Okay, so we have to do 2x minus 3 over x plus 5 equals what over x plus 5, x plus 3? So what is this missing to become this? It's missing an x plus 3. And this is a place where a lot of students made mistakes. You got to FOIL. You got to double distribute. You got to do 2x times x, 2x times 3, negative 3 times x, negative 3 times 3, giving us 2x squared plus 6x minus 3x minus 9, which simplifies to 2x squared plus 3x minus 9. And then this already has the same denominator, so we're just going to keep this. All right, now we have like denominators. Let's take the numerators and put them over one denominator. Minus, now that minus, I have to do parentheses, all over x plus 5, x plus 3. Let's distribute this negative. This negative goes to each of these. So let's rewrite this. This is not green. This is 2x squared plus 3x minus 9 minus x squared plus 4x plus 19 all over x plus 5, x plus 3. So like terms, 2x squared and negative x squared gives us x squared. Positive 3x, positive 4x gives us positive 7x. Negative 9, positive 19 gives us positive 10 over x plus 5, x plus 3. Now, you're not done. You're not done. We have to check and see, can we factor that? In fact, we can. Factors of 10 when added equals 7 are x plus 5 and x plus 2 over x plus 5, x plus 3. That means these cancel. Boom, boom. And my final answer is x plus 2 over x plus 3. And we are done. So that's what your assessment's going to be like. So there are lots of extra problems that I put on Google Classroom for you to practice this weekend. You will have a pre-assessment on Monday, and then you will have your assessment on Tuesday. So hopefully you're going to use the time. Let's talk about the fun extra problems. So what I would advise you to do is I would take this and do it. I would just take this one and do 2 minus 1/3. Well, 2 in thirds is going to be 6 thirds minus 1/3, which simplifies to 5 thirds. So that numerator simplified to 5 thirds. So let's put that 5 thirds. And now let's take this other part and let's simplify that. Okay, so if we simplify that, that is 4 plus 11 thirds. And 4 in thirds is going to be 12 thirds. That's equivalent to 4 plus 11 thirds, which is 23 thirds. And that's our division. So division right here, that's this. And then we have 23 thirds. Now, a lot of people stopped here. And this is division. So we can convert this to 5 thirds divided by 23 thirds. And now we can convert. We keep, change, and flip. 5 thirds times, we're going to convert it to multiplication. We're going to take the reciprocal, and the 3 in the numerator cancels with the 3 in the denominator, giving me a final answer of 5/23. There are a lot of people who got that right, so that was good. I was really happy to see that. I will show you another technique that you can use. Copy. I'll show you another technique, which is nice. You can look at the denominators here. What's the common denominator? 3. And the common denominator there. So if we multiply by 3 over 3, I'm going to distribute it to there. That gives me 6. I'm going to distribute it to here. That gives me -1. I'm going to distribute it to here, which makes 12. and I'm going to distribute to here, which is plus 11. And 6 minus 1 is 5. 12 plus 11 is 23. That's the most efficient way, is you cancel out these denominators. Now you got to find the common denominator of all four of these denominators, all these four terms. Okay, so it can't be 3 here and 4 because that's not going to be a value of 1. I'm multiplying by a value of 1. So I haven't changed anything. I just got rid of those denominators in that efficient way. So we could do that here, or we could separate them again. We can do each piece by itself. We can do this problem, 2 minus 4 over x plus 2. Denominator is going to be x plus 2. I'm going to find an equivalency. 2 times 2 over 1 equals what over x plus 2? We multiply it by x plus 2. X plus 2, which gives me, which gives me 2x plus 4. So 2x plus 4, and then the 4 that's already there. So now we can put them all over the same. You have 2x plus 4 minus 4 all over x plus 2. And that simplifies to 2x over x plus 2. So this numerator simplifies to 2x over x plus 2. Now we can do the denominator. We can do this one. And we have, let's do this. We have 5 minus 10 over x plus 2. X plus 2 is the common denominator. And so we do equivalency. 5 over 1 equals what over x plus 2? We're going to multiply it by x plus 2. X plus 2 gives me 5x plus 10. So 5x plus 10 and 10 here. And then let's move that. That is kind of in the way. We'll move it. Let's move this down a little bit. Let's move this over a little bit. There we go. All right. So this gives us 5x plus 10 minus 10 over x plus 2, which simplifies to 5x over x plus 2. That's here, 5x over x plus 2. Now we're going to change this in a different writing. We'll do 2x over x plus 2 divided by 5x over x plus 2. We'll convert it, keep, switch, and flip. Now, numerator, denominator. Hey, that x also cancels because it's being multiplied, leaving us with 2 over 5. And I'll show you the technique, the other technique, copy, of getting rid of the denominators. So we look at the denominators. We have 1, x plus 2, 1, x plus 2. So my common denominator is x plus 2 over x plus 2. And I'm going to multiply everything. That's going to be 2 times x plus 2. And this will cancel. Numerator cancels with denominator, leaving me with negative 4 over. We'll take this x plus 2 and times it by 5. That's 5 times x plus 2. And then we'll multiply it by this. Numerator cancels with denominator, leaving me with negative 10. This is 2x plus 4 minus 4 over 5x plus 10 minus 10. These cancel. You're left with 2x over 5x, and that's multiplication, so we can see that my x's are going to cancel, and I'm left with 2 over 5. That's the high school way. You're going to see lots of high school students doing it in that manner. All right, good luck. Sorry I'm not there. I'll see you on Monday. Enjoy. Practice, please.